Howdy folks. So I'm down at my parents' house again, and as always I can never just come down for a little bit of a holiday. I always have to do something, and in this case it's an amplifier repair. If you've watched my previous video where I went over my parents' AV setup, you would have seen the other amplifiers that this one goes with. So this is a NuVo model NV-P2100. This is just a Class D 200 watt power amplifier stereo. There are two of these units and one master unit, which has a lot more channels. These are just stereo, like single device, single output. And the other one, there's a big one which has a bunch of channels, and then there's another one of these. And these two separate units drive two sets of outdoor speakers, one on a patio and one in a garden. And this is the one that drives the patio speakers, which are actually up in the ceiling. And anyway, this amp, I came home and the protect light, it has a speaker protect light, and it was on, and the active light was off. And it's been in speaker protect for I don't know how long. And I checked the speakers. The speakers are fine. There's no shorts or anything. So the amp obviously has some internal fault, and I'm going to be trying with the little tools I have to try and diagnose the issue. And by little tools, I mean I have a multimeter and a screwdriver, maybe a soldering iron. That's about it. So anyway, just a little bit of a teardown and possibly trying to troubleshoot this. I apologize if the audio is echoey, but unfortunately this is the kind of the best room I've got. So anyway, on the back, we've just got the audio inputs and outputs, which is just like a pass-through. We have some gain controls, switching on and off, because it's designed for an automation system, speaker output, and IEC mains. The speaker output's designed for 4 ohms, as well as 8 ohms, but it's definitely 8 ohm speakers, given the impedances that I was reading with my meter. So anyway, it's time to get the case off and see what's inside. Okay, so I've removed all the screws. There was just 5 on the back and 3 on each side. And this thing weighs a hell of a lot, by the way. I would say this thing weighs like probably 30 pounds. So I suspect it's probably got a big transformer in it. I can kind of see something through the vents. So assuming that this just kind of slides off, which it appears to. Got a lip caught on the back. There we go. And we are off. So you can see they've just obviously painted the outside, and some of it's coming through the inside, but they don't really care about that. And we're in. So this is an interesting looking amplifier. It is sort of what I kind of feared, in that this is a monolithic block amplifier, which I mean is kind of common. It's kind of what you'd expect, because I mean it's cheap and usually quite effective, but those chips are not easy to source. So I'm a little bit concerned already. But anyway, so we've got our really nice power transformer here. And this one says it's got an internal fuse, Shanghai SK transformer, primary 120 to 240, 50-60 hertz. And I'm not quite sure what the output winding is. It's ambiguous. So anyway, this is the second time I've seen this type of transformer. If you watched my teardown of the A10 function generator, I noticed it had a transformer that looked like this with the actual core. It was this sort of round core shape. So this is now the second time I've seen that type of transformer, but you don't see these very often. I do like the look of these. This is not nearly as well made as the other transformer, but at the end of the day, I mean, it doesn't really matter how it looks, it's how it works, right? And I don't suspect there's anything wrong with the transformer, of course, because it would power up, and it powers up fine. So that's not the issue. We've just got a little board down the front, which is just for basically the on-off switch and 2 LEDs, so there's nothing interesting there. And all of the rest is on this board at the back. So let me bring you in a little closer and we'll take a look. So here is our amplifier section here. So obviously we've got our heatsink and our giant monolithic amplifier module. Now this says high efficiency on it, and my guess is that this is a Class D amplifier. So this is a digital PWM amplifier. The idea behind Class D is that transistors are more efficient when they're either fully off or fully on. So basically you create a high frequency pulse width modulated signal, which you then integrate, and that gives you an analog output. It's not as clean a signal, it's not as free of distortion and stuff as a regular analog amplifier, but the idea is that it's a lot more efficient, and for something like this that's on all the time, you want it to be as efficient as possible. So I'm guessing, I'm going to look up that part number and see exactly what it is, but we've got 2 giant electrolytics here, 10,000 microfarads at 63 volts a piece by TFY. I've never heard of them before. Don't see a temperature rating on those either, which is not great. Sorry, I'm sniffing a little bit. It's very. I think I'm coming down with a cold. So we can see there's a little thermocouple here, just kind of touching the. Hopefully you can see that. There's a little tiny thermocouple just sitting on the. It's not even attached. It's just kind of touching the actual heatsink, and that's obviously for over temperature protection, because the manual says that protect light will come on in one of 2 cases, either over temperature or there's been an external short. Well, they also forget to mention that it can also be the amplifier's fault too. So that's clearly what this is. So it does have over temperature protection, which is nice. We've got some more power supply stuff, more power supply caps here. They've gone with all the same brand, TFY for everything, and they've really gone to town with the glue. It's not hot snot. It's that brown glue, which is really hard. It goes on like hot glue, but it almost looks like it's that stuff that really that corrodes PCBs. It almost looks like that, but it might not be, because I haven't seen a piece of equipment do that in a while. So anyway, so we've got our transformer input comes in here. We've got 2, not 1, but 2 pretty decent sized bridge rectifiers. These are actually in the proper bridge rectifier package here, no discrete diodes, and they're not heat sinked to anything. We've got some filter suppression capacitors. We actually have a date, actually, I just realized this. NuVo P2100 PCB 2013-214 version 1.6. So this is an old part. This house, which was built in I think 2007, 2008, had these installed, and they would have been still sold at that point. So this particular amp was not manufactured in 2003. It's much newer than that, but it's obviously an old design, and they discontinued it within the last few years. We've got our speaker protect relay here. I'm assuming that's it because I don't see any of the relays here. We've got a little riser card here, which it does plug in, or they've soldered it. They have soldered it. Okay. There's a little riser card which has got just a bunch of passives on one side and an IC on the other side. And I can't quite read the markings on that. Let me see if I can get some light. I don't have a flashlight, so I'm going to resort to using my phone. It is an AS39 AS339M-E1 by a manufacturer whose marking I don't particularly recognize. So my guess is, just given its proximity to the speaker protect relay, that would be a speaker protect bias, just basically a DC offset check circuit that they've got in a module. That's my guess. We've just got some coils, some power resistors in quite an odd package. They need 4 of them, which they look to be in parallel. Just some jelly bean logic parts here. Some op amps. There's 3 JRC op amps here, some opto isolators, and this part here, which is a Texas Instruments 7400 series. It's an HCO2. So really just sort of jelly bean parts, with the exception of the actual amplifier module itself. And going in closer to the back, you can see just all the jacks there, and it's kind of interesting. This speaker output here, they've basically removed the solder mask, and they've wave soldered this to give some higher current carrying capability to these traces. And you can actually see there's little beads of solder right at the ends of where they've actually stopped that and where the solder mask is. So I'm assuming that there's a via under there, and the solder has just kind of pooled there. But that's a very common technique to reduce the resistance of a trace, which they most likely did after the fact, maybe in a later revision. They realized, oh, those traces are getting a bit too hot. Let's take the solder mask off, and rather than redoing it with a wider trace, let's just use solder, because solder's free basically when you're manufacturing things. So that's the only kind of thing I don't like, is the quality of the solder job there. I don't really see any other major no-nos in the design of this. They've got the heatsink attached with screws to the actual board itself, so they've got little mount down here in the corner, and they've just screwed it directly on, and they've done that on both sides. So I don't see anything really bad with the design of this. They've got a ground lug, which is actually it's got a spade terminal. It's a locking type, and that goes over to, there's 2 actually. Yeah, so there's actually, they've connected the ground to a screw right on the side of the chassis, so the chassis is directly grounded, and it also goes off to the actual power transformer. So they've grounded this in 2 places, which is good. So what I want to do is I want to power this up, and I want to measure the output, which I expect will be 0 because the speaker protect relay won't be firing. But I want to probe the pins of this chip. I'm going to look up what this is, get a pin out for it. Hopefully it has a data sheet that I can get. And I'm going to probe the pins and see if there's clearly an output that's jammed to the positive supply rail or something that would indicate that something internally is shorted in this chip. Because this chip is what I'm suspecting just off the bat, because it's kind of the most common thing to fail. When something goes into just a permanent speaker protect like this. It's very possible that something else has failed in the speaker protect logic, or a buffer or something like that. So it could also be an input chip, like one of the op amps on the input has blown, and it's now locked to a rail. So the input is tied high, and that's after an AC coupling filter or AC coupling cap. So it's possible that they just didn't expect that. So there's all sorts of things that could be wrong. So let me figure out what this chip is and probe around for some voltages, and I'll see if I can come up with anything. So I looked up that monolithic power amplifier chip, and it's a Sanyo STK412-030, and I was wrong. It actually isn't Class D, it's Class H, and Class H is the highest efficiency Class AB variant you can get. I own another amplifier which is a Class H, and it's the one I use in my home theater system. And so I'm familiar with Class H amplifiers. Basically, the idea of Class H is it's a Class AB, but basically it has several taps, and the idea is that it infinitely varies the power supply so that the amplifier is only dissipating the smallest possible amount of power at every amplitude level. It's an interesting design, but you usually only see it in these amplifier packages. You don't see it done with discrete components. So this is not very surprising. Now I haven't checked to see the availability of this chip yet, and I don't really want to go there. I want to confirm that the chip is indeed what's wrong first. And this data sheet is really the only data sheet that I can find on this chip, and it's not terribly great. It does give me a whole bunch of absolute maximum ratings and all sorts of stuff like that. But the most useful part is not the sample or the equivalent circuit. It's the sample circuit, and they don't even tell you what the pins are called or what they do. You just sort of you imply that based on the internal block diagram or this sample circuit. And the thing that you'll note is the sample circuit. There's a couple things on this that make me think that they've probably implemented the sample circuit in this amplifier, because most engineers are lazy, and if someone gives a sample circuit that works really well, there's really no reason why in a component like this, it's not really built down to a price, why you wouldn't just do this sample circuit. And you'll notice that right here it shows these 4 resistors right here, and it says that those are some cement resistors, 0.22 ohms, 5 watts. Well, if you remember, there were those 4 big white ceramic power resistors, and I bet that's what those are, which means that there's a good likelihood that they're using something very similar, not exact, but very similar to this sample circuit. So what I want to do is I'm going to basically turn it on. I'm going to go through all the pins, and I'm going to measure the voltages, and then I'm going to come back to this diagram and basically cross-reference all of them and see if there's anything that clearly looks out of place, and see what I can determine from that. My hope is that it doesn't turn on immediately, go into speaker protect, and then power off this chip somehow. Because if it powers off this chip, then of course everything's just going to turn off, and I'm not going to get any data out of it. But I don't think that there is a way to turn this chip off, so I'm going to hope that I can just measure this while the thing's on in speaker protect. So wish me luck. So I have the voltage measurements across the 18 pins of the device, and it's horribly written down, but I'll summarize what I've got. I've cross-referenced this with the sample circuit as well as the internal diagram, and all the power supply rails are there, both negative and positive, as both the high and the low voltage supply, as well as the divided supply. All of the stuff that goes through the diode drops on this side is also fine. The issue does not appear to be with this module, which is sort of like a thank God, because you'll notice that the input, which is on pin 18 and pin 14, they're both sitting at negative 200 and negative 197 millivolts, which of course that should be 0 because I've measured the voltage on the actual input banana jacks, and it's 0 on both of those. And the output banana jacks are also 0, or not banana jacks, RCA jacks. They're both 0. So obviously there's nothing wrong at the actual input, but the input to this chip is low, and of course the output is sitting at negative 22 millivolts, and the other output is on pin 9, so negative 30 and negative 22 millivolts respectively. So obviously there is definitely an input issue, and of course there's going to be an output DC offset issue as well. So it doesn't appear that this chip is faulty, because if those the big issue of course is if that negative input is being caused by the chip, we don't know. It could be something is feeding in a negative signal, or it could be that this chip is pulling the line negative because it's faulted somehow. But I highly doubt that. I think that this is most certainly just something else, probably an input op amp or something that's finally gone. So I'm going to try and trace out the board and see if I can find the preamplifier that's probably causing this issue, because that's what I think it is. I think it's one of the op amps that boosts the line level into the preamp that this thing needs. I think one of those op amps has probably gone. So I'm going to hopefully see if I can find that. So I did a bit more digging, and I started drawing up the schematic for it, and I'm really definitely sick now. So I was doing the schematic, and I was drawing out from the input to the what I'm calling the preamps, and then I got to a point where I lost the traces on the other side. So I decided to trace back from the input pins of this chip back, and I got so far, and the input for, I believe channel 1 is the last pin, pin 18, it was sitting at minus 200 millivolts, and it's what I'd written down when I originally took my, minus 197. That was originally what I took before. And then that sort of suddenly changed without me doing anything to minus 160 millivolts, which I thought was odd. So I checked the other channel, which according to my original test was pin 14 minus 200 millivolts. It's now sitting at plus 28 volts. Yeah. And the thing is, that's rising. The longer that I leave it on for, it creeps up to about 32, 33 volts. And of course, that's really not good. It's very likely that if this wasn't the problem, it probably is dead now, because I'm going to check the datasheet, but I don't think it's designed to handle that kind of input voltage. I think it's just killed itself. If it wasn't the problem, it's dead now. If it was the problem, now it's just showing its symptoms a lot more. Because I don't know how you could. I mean, it's got to be higher than the 24 volt rail, and I don't think the 24 volt rail is present. I know it's present. There's an LM78L05 here, which has a 24 volt input. But I think to get anything above 24 volts, you have to get it from the main supply. And I think this is the only thing that has that supply. So the fact that there's 30-something volts on one of those pins, pretty much, it kind of confirms that this definitely is backfeeding power to the input. So I think this is faulted now. I have my thermal camera with me, because I always usually just pack it, because I mean it's super tiny, right? And it came in handy yet again. So I was using that to see what was going on. The 7805 was pretty hot, but it was working fine. These are actually not very hot, those op amps. I don't suspect the op amps at all. But there was a couple resistors that were really hot right in this area here, and these couple capacitors were getting really hot, like plus 60 or higher. And I think the reason is because they're not rated for the voltages that they're now dealing with. So let's see if I can find a voltage rating. So they're 25 volt capacitors. So of course, with the almost 35 volts on there, they're being overvolted, and of course they're dissipating a lot of power. They haven't blown their tops yet, but I shut it off before I started seeing little popcorn explosions from these caps. So it doesn't look too good for this. It really doesn't, and I'm suspecting this. So I finally took it out of the case. It was actually pretty easy. They actually just, basically there's two screws on the bottom which go into the heatsink, and then there's just a couple screws that hold the speaker terminal and the RCA terminal on, and the board is just sort of suspended through those, and the board just comes right out. There's nothing interesting at all on the back. They've just removed some solder mask from some key power traces, and sort of as you'd expect, and nothing else special going on there. It's all single-sided, of course, makes it nice and cheap. So I've looked at the circuit, and I can't seem to find anywhere that the plus minus 50 volt supply goes other than to this chip. It doesn't seem to go anywhere else. So given that this thing is putting out now like 37 volts on the input pin,
And these caps, by the way, are actually rated for 16 volts, 25 and 16 volts respectively, and they've got almost 40 volts across them. So I've managed to find on eBay. I managed to find this particular part from the U.S. for about $30. So I'm going to ask my parents, see what they say. Of course, this is theirs; they can choose to do whatever they want. But I'll ask if they want me to order this. And I'll also probably order some caps, just because I don't trust these now that they've been severely overvolted and overheated. But I would just order those at probably $35 and everything. To give it a shot. Because I looked this up. This is a discontinued amp. Seems to be they were going for about $475 US when they were discontinued. You could probably buy them used for probably half that, but it's still a hell of a lot more than $30. So it's going to probably end up. It's going to be entirely my parents' call, pretty much. So yeah, that's pretty much the state of this. I will inform them, find out, and if they went ahead with the purchase of this, the next segment of the video will be me installing it, pretty much.
So it's been about 2 or 3 weeks, and I'm back home now, and I've got this with me, and I have a new amp module. So I ordered this from eBay, and it actually arrived pretty quickly. I had to wait for this thing to get to me. But now I've got all the pieces, and I want to try replacing this and see if I can bring life back to this. So this thing is, it's just a hybrid module. I kind of wanted to see inside this. Maybe I'll crack this one apart, and we can see if we can see anything at all. It's probably potted, but it's just so light that it might not be. So yeah, I hope this is genuine. I really have no way of knowing. I mean, there's no markings on these things. It looks the same. So anyway, I guess all that really matters is if it works, right? So I've got my my desoldering iron, and I'm going to start basically by the way I think I'm going to do this is I'm going to desolder the pins on the bottom, and then I'm going to release the screws which take the heatsink off, and then I'll once the heatsink's physically separated, then I'll just unscrew this. So I will do that and come back when it's off. So I finally got the part off. I hate these high thermal mass, relatively high pin count packages. Anyway, I wasn't actually able to get the heatsink off because the screws that actually go through this are in between the fins, and I don't own a screwdriver that is thin enough to actually get all the way down. So I just ended up taking it off with the heatsink still on. It made things a little bit difficult. I mean, my desoldering iron got me, a pretty decent amount of the way, and then I had to use a combination of solder wick and the soldering iron basically manually to get this off. It was not easy, especially because all this stuff's in the way. But and I managed to not get grease on everything, so that's good. I'm not even going to bother to clean this. I'm just going to add a little bit more to sort of supplement what came off the original. The actual thing came with that tiny little packet of stuff, so it should be fine. So yeah, I'm just going to insert the new module in there, solder it from the other side, and pretty much just power this thing up. There's really not much else to do. So I've got the new module installed with a bit extra thermal compound. So it's all soldered in, screwed back on. I've put it back in the enclosure. I have not screwed the actual board back into this yet, because I'm just going to plug it in and do the live on camera initial power up, and we will see what happens. I mean, I don't know what's gonna happen, to be honest. Best case scenario, it powers up, speaker protect shuts down, and then I know that at least there's no DC offset. Then I'll get out my scope and I'll plug a source into it and actually analyze the output, and then I'll hook some speakers up to it. But we're going to do this in stages. So I haven't even plugged the power in yet because this thing doesn't have an off switch. So as soon as I plug this in, it's going to draw a massive gulp of current. And hopefully it doesn't blow the circuit breaker in my room, because I know these caps have a really high surge current. I hope they don't trip anything, because I'm drawing a lot of power at the moment with all my file servers running away and stuff. So let's plug this in. Okay, so no explosions. So let's turn it on and see what happens. Okay, so it goes into protect mode still. So what that basically tells me is that there is still a problem here, and it's not that module. So, this is a bit interesting, because whatever it was clearly killed that module. So I don't particularly want to leave this thing plugged in and do a lot more troubleshooting with it on, unless I know what I'm doing beforehand, because I don't want to blow a second module. That would be a bit shitty. So let me think about this for a moment. So now that I'm taking a closer look at this board, there's a bunch of stuff that's sort of standing out to me. Like, look at that 74 series logic part right there in the middle. It's on an angle, and if you look at the back side of the board, this is the footprint for that chip. It's not even in the board all the way on the left-hand side. I mean, you can see the pins on the right side, but on the left side, they're just not there. I mean, it's not even on the bottom. They're smooth. Like, there's pins here, and this is all smooth. So they didn't even put the insert the chip all the way. So what I'm gonna do is I'm gonna go through and manually reflow all of the solder joints on this, just to in case that there's a cracked solder joint somewhere, and then I'll if that doesn't work, I'm gonna try and do as many resistance measurements as I can. I'll probably start taking components off as part of the preamp circuit and testing them out of circuit with my LCR meter, and see what's going on. See if I can isolate if it's a failed passive, or if there's actually like a semiconductor part that's failed, because it's more difficult to test the semiconductor parts. So I'll move on to that after I deal with the passives and the solder joints. Okay, so I went through and I reflowed every single joint on the back of this thing. Holy shit, when you look at this up close, this has one of the worst soldering jobs of a product this price I think I've ever seen. It's horrible. So yeah, I reflowed everything. That didn't correct the problem, but I mean, I might as well try. So then I thought, okay, I'm going to start testing passives. So I got out my semiconductor analyzer, and I checked all the diodes and voltage regulators and stuff. The diodes all checked out good. This thing is supposed to be able to do voltage regulators, but it wasn't able to figure out what any of them were. So I think it's simply this that is actually just not working on those devices. I don't think that they're all blown. Like, it couldn't even detect transistors, which I thought was very odd. So I may take the components out of the circuit. But anyway, while I had this out, I decided to use my ESR meter to test the caps. And that's when I noticed something. I went through and tested every electrolytic in this, and I marked them with a red top if they are bad. And almost all the caps in this are completely toast. The big main electrolytic filters are okay, but everything else is completely fucked. There's 1, 2, 3 caps that are actually okay, out of all the small ones. So whatever this company TT or TFY is, they make shit caps, because these are horrible. Like a lot of the small ones, like the 2 microfarad and those ones, their ESR is like 5 ohms or greater. Some of them that are supposed to be like 100 microfarads are measuring like 30, if that. I have some of them that have an ESR that's like greater than 40 ohms. Like, this thing can't even measure it, and there's no resistors in parallel with the caps. Like, their ESR is just completely fucked. So it's possible that like, and some of these are just straight up leaky. Like I can't even get a capacitance value because they're just leaking so hard. So it's possible that the caps are physically leaking, like like some of these are supposed to be like bypass caps and stuff like that. It's very possible that some of these are leaking DC through them, and that's what's causing the output to be DC biased, is because the caps, which are supposed to be blocking the DC, are leaking the DC through them. So it's very possible that it's a cap issue. So I'm gonna have to talk with the owner and see if they are willing to spend the money to replace the caps. I mean, it's not a terrible expense. The other thing that this sort of raises the question on is, because we have 2 of these and the other one hasn't failed yet. So the question is, what are the state of the capacitors in that one, and does it have a risk of imminent failure? Because if it does, and the owner decides to buy caps, I might as well double up and replace the caps in the other unit when I get a chance as well. Because of course, I mean, if it blows this chip in the other one, then that's another $30 we don't need to spend. So anyway, I'll look into that. At this point, I'm gonna maybe continue to test some passives, maybe look at the resistors and stuff, because they can be measured in circuit relatively easily. I've tested the optos, they seem to be fine. The op amps I can't really test, and the small ceramic caps I'm not really going to bother to test because failing ceramics is incredibly low, and I'd have to really take them out of circuit to measure them properly anyway. So yeah, I'm just going to test a couple resistors, more of the power resistors, make sure that they're still okay, none of them have blown up and there's no magic smoke emitted and anything like that. And then I'll talk to the owner and see what we can do about the caps. But yeah, it's really fucked. I was not expecting the caps to be that bad, but yeah, they're bad. And I don't know if this was original or if it was due to the old failed chip, because the old failed chip put out some pretty high voltages on these rails that some of these caps, particularly these 2 in particular, were not rated for. So it's possible that the backfeeding of the 25 volt rail, or the 50 volt rail into the 25 and the 16 volt rails killed these caps. But there are some that are not even on those power supply rails. They're on like the 5 volt rail and stuff that's generated by this little regulator 78L05 and stuff. So these caps, which are on that rail, they're not related. So the fact that they've failed in the exact same way makes me think that maybe these caps were not a result of the old amp module failing, but they were always bad. I didn't check these before because I wasn't in my house. I didn't have all of my test gear with me. So yeah. So I'm gonna ask the owner, see what we can do about it. But yeah, for now it's not looking terribly good. So I got sort of the go ahead to continue with the project, but it was kind of like be cautious of going too far. So what I thought I would do was I'd go through my random parts bin and see what kind of capacitors I already owned that I could just kind of tack in place. So what I did was I went through all the caps again. Of the 18 that were bad, I picked 8 of them which were the worst. And these were the ones that were leaky and stuff like that. So I pulled them out of circuit and I actually measured them. And in fact, I have them all here. And these were all of the worst of the worst. And once they were out of circuit, I actually, testing them out of circuit is really the only real way you can get a good value from these. And they were all leaky. So some of them that even measured like just, bad ESR or bad capacitance in circuit actually are completely leaky out of circuit. So interesting. So anyway, I replaced the worst 8 capacitors with just random shit that I had lying around. Some of them were new, but I believe almost all of them were old. So I just kind of tacked them in. Some of them I didn't cut the leads because I wanted to keep the leads long so I can reuse the caps. Some of them are really ancient from like the 80s, but I tested all these caps and these are not great, but they're better than the ones I pulled out. So basically, now that I've done this, I want to try it and see see if anything changes. And I want to keep replacing caps at this point until I either run out of caps to change or it does something. I don't expect it to be good, but like I don't expect it to work well with the caps that are still in here. But all I want to do is I want to see it come out of speaker protect. If it comes out of speaker protect, then that proves that that was what killed it, and that was why it wasn't working. So if I can get it to come out of speaker protect, then I've basically got the green light to go ahead and order new parts for this. So again, I'm going to do the same thing I did before, and I'm going to do a live power up test. So let's see what happens. So we'll make sure it's off or in standby, and power cable is going in. Okay, so it's energized. So let's flip the power. Oh, look at that! It's active. So speaker protect is disabled, so the amplifier has no more DC offset at the output. So the amp is running now. So I could theoretically feed a signal in, and I should be able to get an output from this. So I'm not really going to bother with that because I think that's it just did that because I just pulled the plug out. So yeah, I think I'm not even going to bother to try and test the signal performance and make sure everything's okay. I'm going to go ahead and order some caps because that's the next step. So yeah, it looks like this is actually gonna be savable once and for all. And it was actually the caps that killed the thing. So I think we're definitely gonna end up buying caps for the other amplifier and replacing them as a matter of course, because they're all gonna be in the same, like, you know, failing state. Because I mean, they were both bought at the same time, installed at the same time, and they've been next to each other side by side their entire lives. So they're gonna have very similar aging characteristics. So I'll get some parts on order, and maybe a couple days later I'll come back to this, replace them properly, and then we can actually get a scope on it and actually make sure that everything is like really okay. So it's a couple days later, and the wonderful bags from DigiKey have arrived, and so I think today's the day to swap out all those really crappy, what were they, like TFY brand caps or whatever, for genuine Panasonic caps, which hopefully will outlive that amp. So time to get the soldering iron out, and get going. So I've finished recapping the amplifier, at least the first one anyway, and so I thought I'd just check now that they're all out of circuit, see how completely fucked these actually were. Some of these I know are going to be really bad, but others it'd be interesting to see out of circuit how they perform. So this is a 100 mic at 100 volts. So that one was fine. The higher voltage ones seem to be, they seem to have fared better. Yeah, so these two were okay. They were sort of part of the power supply, but I wanted to change them anyway because they were close enough to the action, shall we say. So this is supposed to be 470 at 16, so that's still okay. Another 470 at 16. Okay, we're getting a bit low on capacitance there. That's not really in tolerance anymore. This is a 220 at 25. Okay, I mean they're all a bit low. This I think is another 470 at 16. The caps are rolling around everywhere. Okay, so far they've been okay. So now let's get on to the smaller capacitors. So we've got 100 mic at 25 volts here. Okay, so there we've got a bit of a problem. The capacitance is only half of what it's supposed to be, and the ESR is 2 ohms. That's too high for my liking. So another one of those 100 mic at 25 volt. Okay, that one's fucked. That's fucked. Let's do that again. Yep, so the ESR is basically, well, it's unmeasurable. And yeah, this thing is not a capacitor anymore, pretty much. So yeah, that one's fucked. And we have another 100 microfarad at 25 volt. Okay, that one's okay. So they're very variable. Yeah, let's move on. What is this? 22 mic, 50 volts. That ESR is high. I mean, it would probably still work, but probably wouldn't sound too great. This is a 2.2 mic at 50 volt. Okay, again, that ESR is far too high. 22 mic, 50 volt. Yeah, no, that's not a capacitor anymore. Another 22 at 50. Yeah, nope, that one's fucked. Another 22 at 50. Okay, that is a resistor now. Okay. 2.2 at 50. Okay, super high ESR. 2.2 at 50. High ESR again. 4.7 at 50. Yeah, nope, that's not a capacitor anymore. 22 at 50. It's pretty shit across the board. What is this guy? This is a 4.7 at 50. Oh no, wait, this is a replacement cap. I don't know how that got into that pile. That one's good. 2.2 at 50. High ESR again. 2.2 at 50. Yeah, no, that's way too high ESR. And 2.2 at 50. Yeah, so quite a few of these were basically no capacitance, and one of them showed as leaky. I claim to remember there were more that showed as leaky before. So it may have to do with temperature, maybe last time since they were powered up. But yeah, these are pretty shit caps. So yeah, TFY brand. I mean, they're not like Samsung or any of those brands that I've tested. They seem to fail a bit quicker, but these didn't last many more years. So yeah, I'd say these are pretty low on the totem pole of caps. So I've got the amp all recapped, and I've got it on my my other desk with my little stereo here, and it's plugged in, and speaker protect is off, as I sort of would have expected after replacing all the caps. And so what I did was I just used my meter and I checked the inputs and the outputs. I'm using this kind of ghetto setup with the output because I don't actually have a terminal block to plug in there. But there was no DC offset on the inputs, and it was about 15 millivolts on the output, which is kind of right at the cusp of, not okay, but it's not bad. That's kind of what you'd expect from a module like this. So I'm not worried about that. So I've just got actually one of the very first MP3 players I ever owned, Rio Forge 512. I managed to find this just, in the, corner case that something blows up. I don't want to plug my phone into this until I've proven that everything's good and okay. So I plugged in one of the channels, and I've got some copyright-free music on this thing, so that I can play stuff, and hopefully this thing doesn't cut out because the battery terminals are really corroded in this thing. But let's see. Yep. That's what happens when you use super old. It's got, it's. I think a battery was left in here way too long, and it really messed up. There's some weird music on this, man. But anyway, let's see if it won't crash this time. That sounds pretty good to me. Okay, let me turn this off and flip those wires around and make sure the other channel is working too. So I flipped it around to the other channel, and let's see what that one sounds like. It sounds exactly the same. So I would say that this amp is fully restored. And I'm going to recap the other one. I've ordered the parts for it. I'm not going to do a video on that because I think that would be a bit boring. I mean, I'm not going to show you recapping. It's quite a boring process. But just know that next time I see the other unit, I will be recapping it. So yeah, this was a super long look at repairing a NuVo NV-P2100 power amplifier. So hopefully this wasn't too cringy and you I don't know, were entertained or learned something. I'm not quite sure. Anyway, thanks for watching.